In this lecture, we will discuss the continuous and the discrete time signals. We can broadly classify signals into two types. The first one is the continuous time signals and the second one is the discrete time signals. We will start our discussion with the continuous time signals. The signals which are specified for every value of time t are called as continuous time signals. That is, in continuous time signals, we can define the signal at any interval of time. Here, t represents the time. Now, these continuous time signals are represented by small x, inside the parenthesis small t, where x is the dependent variable and small t is the independent variable. Now, we can see that this signal x t is a single variable signal because we have only one variable and that is the time t. Now, let us see some examples of the continuous time signals. We can see from this figure, these are examples of continuous time signals. Now, in continuous time signals, the y-axis always represents the function or the signal and the x-axis represents the independent variable. So, here we find that xt is the function or the signal, so it has been represented by y-axis, and t is the independent variable, so it has been plotted along the x-axis. So, we find that this x-axis is for time, so this is plus t and this is for minus t. And here we are finding that there is one signal which is having amplitude of a at t0 and the signal goes on decreasing and it becomes 0 at time t2. Similarly, it decreases and it becomes 0 again at minus t2 and the value remains 0 thereafter, that is after t2 its value of the signal remains 0. Similarly, after minus t2 also the value of the signal remains 0. So, this value remains 0 till t is equal to infinity. Similarly, this side also it remains 0 up to t is equal to minus infinity. Now, we can call this signal as continuous time signal because we see that this signal is specified for every value of the time t. That is, we can find out the value of this signal xt for the time t ranging from minus infinity to plus infinity. Similarly, if we observe this signal, we find that we can find the value of xt for any interval of time t. That is, we can find out the value of this sine wave at t is equal to 0.4, 0.5, 1.7, 2.8, 3.5 by drawing a perpendicular to this x-axis and taking its plot on the y-axis. So, we can determine the value of this signal at all the intervals of time t. Similarly, let us consider this signal which is a triangular wave. Even for this function, it is possible to find out the value of this function xt at all the intervals of time t. So, these are examples of continuous time signals. That is, in case of continuous time signal, we can find out the value of the signal xt for every value of time t from minus infinity to plus infinity. So, that is all about continuous time signals. Now, let us discuss the discrete time signals. The discrete time signals are the signals which are specified only at discrete time intervals. that is at discrete values of time. We can define these signal only at discrete intervals of time. That is, we cannot find the value of these signals at all intervals of time. We can find its value only at discrete values of time. In short, we can write the discrete time signals as DTS, and the representation of a DTS signal is done by small x inside the square bracket small n. Now this small n is not time, but it is an integer. So it is different from continuous time signal, because in discrete time signal there is a square bracket in place of parenthesis in continuous time signal, and we have an integer n here in place of t in continuous time signal. So here the dependent variable is x and the independent variable is n. Now we will draw the plot of the discrete time signal using the plot of the continuous time signal shown in this figure. Now from the definition of the discrete time signal, we know that a discrete time signal is specified at discrete time intervals. That is, it is not specified for every value of the time t, but it is specified only at discrete time intervals. So let us say that this signal xt is specified at t0, t1, t2, t3, t4, similarly at minus t1, minus t2, minus t3 and so on, and let the value of xt be a at t0 and the value of this xt at t1 is equal to this much. Similarly, the value at minus t1 is this much. The value of xt is 0 at t2. The value of xt is again 0 at minus t2. The value of xt is 0 at t3. Value of xt is again 0 at minus t3. Similarly, we can find the value at t4 is also 0, at t5 is also 0, and so on. So, if we want to find the value of the discrete time signal from between the time from t1 to t0, then we cannot find its value because it is not defined inside this interval. So let us draw a plot of the discrete time signal from this continuous time signal, which will come out to be as shown in this figure, because it is defined at t0. At t0 the value is a, at t1 the value was this much, so we have drawn here. Similarly, at minus t1 this is the value, so we have plotted it here, and at t2 the value of the signal xt is 0. Similarly, at minus t2 also it is equal to 0, and it is 0 at t3, t4, t5, minus t3, minus t4 and so on. So we have plotted this discrete time signal from the continuous time signal. So we find that this signal is defined only at discrete intervals of time. Now we discretize the time axis. The y-axis is for xn and the x-axis is for the integer n. Now at t0 we find that the value of the signal is a. At t1 we have found out the value and we have plotted it here. At t2 we find that the value of the signal is 0. At t3 again it is 0, and so on. So this is the plot of the discrete time signal. Now let us denote the time interval between t1 t0 by delta t. That is, delta t is the time interval between t1 t0, t2 t1 T3, T2 and so on. So we can write delta T as T1 minus T0. Then T2 minus T1 is also delta T, T3 minus T1 is T2 is also delta T and so on. Now this delta T may be the same in each case. So if delta T is equal in each case, then we can say that the signal is uniformly sampled. In that case, we can write delta T is equal to T1 minus T0 is equal to T2 minus T1 is equal to T3 minus T2 is equal to Tn minus Tn minus 1 and so on. So if the discrete time signal is uniformly sampled, that is when delta T is equal in each case, then we can say that this is uniformly sampled. And when the time interval delta T is not the same in each case, then we say that the signal is non-uniformly sampled. Now we will discuss the existence of a very important thing, that is the existence of this integer. So we can see that this x-axis is for the time, but how we got the integer here as the independent variable. So let us consider the case of uniformly sampled signal. So because of this, delta T will remain the same because it is a uniformly sampled signal. So let us say that delta T is the time interval and it is equal to capital T. So if delta T is equal to capital T, then T1 minus T0 will be equal to capital T. Similarly, T2 minus T1 will also be equal to capital T. T3 minus T2 will also equal to capital T. And Tn minus 1 will also be equal to capital T. So let us assume that T0 is equal to 0. So in that case, we can write T1 minus 0 as capital T. Similarly, we can write T2 as 2T. T3 can be written as 3T and this T can be written as NT and so on. And if we are having T as the independent variable, so we cannot write xn. In that case, we will have to write xnt. So we have written xnt here. Now we cancel out T from here and also from here, so that this becomes 0, 1, 2, 3 and so on. So now we find that this T cancels out. So this axis is for the integer n. Similarly, here also T cancels out. So this axis is for xn. So that is why we are having integer values along this axis as 0, 1, 2, 3, 4 and so on. And along the y-axis we have xn. So this is the case of discrete time signal. That is why we are taking n as the independent variable here and xn as the dependent variable in this case. Now let us consider this signal. This signal has been obtained from the sine wave of this figure. So from the sine wave of this figure, we have specified this signal at discrete intervals of time, and from this plot we have obtained this discrete time signal, because this signal is not specified at all intervals of time, but it is only specified at certain discrete intervals of time. So this is a discrete time signal. So that's all about continuous time signals and discrete time signals. Hope this is clear to all of you. So see you in the next presentation.